Okay, so now we're getting into balancing equations. So for this one here, okay, I've actually given you the formulas for you. You've got a compound that breaks apart into two pieces. So that tells us that this reaction is going to be decomposition. From there, again, if you want, feel free to count atoms and break it down if you need to. I'm going to look and I say, okay, silver is good. Chlorine, 1 and 1, good. Oxygen, I have 2 here. I'm sorry, 3 here and 2 on this side. So the least common denominator for oxygen is going to be 6. And so I'm going to go ahead and put a 3 here and a 2 here. By doing that, I have now unbalanced silver and chlorine. 2 silvers here, 1 here, so I stick a 2 there. By adding that 2, it fixed chlorine as well. Okay, so that one is balanced. So for 87, I've also given the formulas for you for the reactant side, but not your product. So here, because iron is a cation, hydrogen's a cation, and sulfate is an anion, I know that iron is going to switch places with hydrogen. So my product side now, I'm going to have hydrogen by itself, and the iron is going to be with the sulfate. Okay, so this question is actually not possible as written because we do not know the charge for the iron. Okay, so I'm going to make a correction here and let us all know that this is going to be iron 3. Okay, so that tells me that it's iron with a +3 charge. So I'm putting that with sulfate, which has a -2 charge. And so the least common denominator is going to be 6, and so iron 2 and sulfate 3. So then I'm left to balance this out. I've got 3 sulfates on this side, 1 on this side, so I stick a 3 here. That 3 has now unbalanced my hydrogens. I've got 6 on this side, only 2 there, so I balance it with a 3 here. Iron, I've got 2 on the product side, 1 on the reactant side, so I put the 2 here. Because this was an element reacting with a compound, I know that this is single replacement. Okay, so for 88, we've got lead 4 nitrate reacting with cadmium phosphite. So this is going to be a double replacement reaction because it's a compound reacting with a compound. Lead is a cation, nitrate is an anion, cadmium is a cation, phosphite is an anion. If it helps, go ahead and just stick those charges in there also to help you keep track of what you're doing. So I'm going to go ahead and switch my cations. Again, it's a personal preference. If you'd like to switch your anions, go for it. It's just whatever you as a person want to do, as long as you are consistent. So we've got cadmium and nitrate, and now we're going to have lead 4 phosphite. So I sort of took it over the line there, so I'm just going to write it below that this was double replacement. Again, I know it's double replacement because I've got a compound reacting with a compound. So then I just need to go ahead and write my formulas. So I've got Pb, NO3, 4. We said cadmium was +2 and phosphite was -3. Now I've got the cadmium with the nitrate and the lead with the phosphite. Because it was lead 4 and phosphite has a -3 charge, that least common denominator is actually going to be 12, and so we need a lot of this stuff. So, like I said, I like to balance my polyatomic ions first. I just like to get them out of the way because they're kind of big and a lot to look at. Okay, so looking at this one, I've got 4 nitrates over here, 2 over there. 2 phosphates over here, 4 over there. So kind of, just pick where you want to start. It's up to you. So let's see, looking at the phosphates, 4 and 2, I'm going to put a 2 here. Looking at my nitrates, I've got 4 over here, and I've got 2 on this side, so I'm tempted to want to put a 2 there. Okay. But in doing that, right, now I look and my cadmiums are no longer balanced. And so if I had 6 here, but only 2 on this side, that 2 is not going to work. And so I'm actually going to get rid of that 2. And I'm going to make it a 6 to balance out the cadmiums. But now that changes my nitrates. I've got 6 times 2, 12 on this side, and only 4 on this side, so I put a 3 in front. By doing that, now my lead has balanced out and it is all set. It's correct. Okay, so for butane reacting with oxygen, I recognize that this is a combustion reaction because I've got a hydrocarbon, which we know is a fuel, reacting with oxygen. When that's the case, we've always got the same products: carbon dioxide and water. Nice thing about these, right? I've given you the formula for your fuel. Oxygen is a diatomic, so it's O2. And then we always have the same products: CO2 and H2O. Remember that when we deal with balancing these problems, we're going to want to do hydrogen first, then carbon, and then oxygen. Okay, it'll just make your life easier. And as another reminder, don't use an odd number, okay, in front of that water. And so I've got 10 hydrogens on this side, 2 on there, so I want to put a 5. There is no way, if I put a 5 there, I'm going to end up with an odd number of oxygens on the product side, and there's no way to get an odd number of oxygens on my reactant side. So to make that odd number even, we're going to go ahead and multiply it by 2, which will make it an even number, which will give me actually 20 hydrogens on that side. So now I need to fix the hydrogens on the reactant side by placing a 2 in front. So because the hydrogens are all set, I move on to carbon. I've got 8 carbons on the reactant side, and so I need to put an 8 in front of our CO2. Then I look at my total number of oxygens. I have 16 here, but don't forget that I had 10 from the water, giving me a total of 26 oxygens. So I have 26 oxygens on that product side and only 2 on the reactant side. And so that tells me I need to use a 13 as my coefficient. Okay, so for number 90, we've got hydroxide and acid. As soon as we see hydroxide and the word acid, that's our clue that we're dealing with a neutralization reaction. I'm just writing it underneath because I know my products, predicting them in words is going to take up more space. So when we have a neutralization reaction right off the bat, we know that one of our products is water. Our other product is made from the cation from the base, so ammonium, and then the anion from our acid. Remember, your hydroic acids are those acids dealing with hydrogen bonded to a nonmetal. So hydrosulfuric tells me that my anion is sulfur. So I'm actually just dealing with ammonium sulfide. Okay, and so now I'm ready to write my formulas. Ammonium's +1, hydroxide's -1. Then we've got hydrosulfuric acid, hydrogen's +1, and sulfur is -2. Remember that for neutralization reactions, we want to write water as HOH. And again, if you don't, that's fine. You're certainly not wrong. It's just going to be easier for you to balance it as HOH. Then our other product, ammonium +1 and sulfide -2. So now I'm ready to write my formulas. Ammonium hydroxide, that's sulfuric acid, and then we've got our products. Again, writing water as HOH to ease in the balancing process. Because ammonium is +1 and sulfur is -2, I'm going to need 2 ammoniums to balance it out. So I check out my balanced equation here. Again, I like to start with those polyatomics. 2 on this side, 1 over here. So I'm going to put that 2 there. By doing that, that made me have 2 hydroxides, 1 over here. So I apply that 2. Having that 2 there changed hydrogen to 2, which was great because we had 2 on that side. Okay, so for 91, we've got zinc plus silver cyanide. Whenever you see that element plus a compound, we know that we are dealing with a single replacement reaction. Zinc is a cation, specifically has a +2 charge. Silver has a +1 charge, and cyanide is -1. Because zinc is a cation, I'm going to need to go ahead and switch the zinc with the silver, always switching cations for cations. So now silver is going to be by itself, and the zinc is going to be with our cyanide. So we end up with zinc by itself is just regular zinc, silver is +1, cyanide is -1. We do that switch, silver by itself is just silver. Zinc is +2 and cyanide is -1, so we need 2 of them to balance it out. So I've got 2 cyanides on the product side, 1 on the reactant side, which tells me I need to include a 2 here. That has now changed my silver to 2 on this side, 1 on the product, and so I apply that 2 on our product side. Okay. And I'm going to stop this video here.